Kindly like the video and subscribe our channel for daily updates.
Are you all done with the assignment that I gave you yesterday?
No.
Okay, fine. Let's get with our query. If you remembered, yesterday we wrote this query. Group by. So have you understood this query, or do anybody have any doubt in this join? Various types of joins. So this is your full outer join that we wrote, group by, because I want department name and number of employees. So in the interview they may give you a relationship like you have countries and you have states, and I want the number of states in each country. So state is the parent table, country is the parent table, state is the child table. One country may have a number of states. So I want to display a report saying that this country has so many states. So you need to write this type of join with group by. Now you can apply all the things that we have learned. Now for example, I want to group by department and gender. Department name, comma, e dot gender. So I need to say group by department name and gender. You see development, and instead of full outer join I'll go for join. Join means inner join. By default if you write join, it's inner join. In development we have females 8, in development we have males 11, in HR we have females 9, in HR we have males 12. So group, then subgroup, group, subgroup, same we did in our last session. Now I want information about males, so I'll write a where clause. So where should I write a where clause? So if I want to get males, so should I write where or having clause? I should write where clause.
Where?
Because it is on column where gender equals to male. So now I'll get the information about males. And I want the information about all the males where number of employees is greater than 10. So WGHO having, because now I'm trying to filter based upon aggregate function. Count of employee ID greater than 10. So is it making sense? Now you got everything from multiple tables, then filter, then group by, then having, then finally it says order by. So this is the same query that we did on single table. Now we are doing the same thing on multiple tables by writing joins. Do anybody have any kind of doubt in this? If you have any doubt, you can ask me. Simple, right? If you have practiced the things that we did yesterday, then you should understand this. Now let us proceed for writing join on multiple tables, on 3 tables. Now you have student ID, subject ID and marks. If you remember, in our day 1 we discussed about this. Student ID, subject ID, marks. Student ID, subject ID, marks. Now here student ID we are getting from student table. Student table has, because the relationship between student and subject is many to many. So you have student ID, which is acting as a foreign key here, and subject ID we are getting from subject table, which is acting as a foreign key here, and we have marks. Now if I want this output, I want student ID, student name, subject name and marks. So with student ID I can join student table and get student name, and with subject ID I can join subject table and I can get subject name, and marks I can display. So now you can see this result we are getting from 3 tables. Marks we are getting from student subject table, subject name we are getting from subject table, name we are getting from student table. Is this clear? Have you understood the requirement? You can type in the comment or in the text chat box yes, no, so that I can get the updates. So here we have a scenario where we want to extract the information from more than 2 tables, that is from 3 tables. Now how do we write this query? Let us see that. First of all, we'll select the columns. Student ID, student dot student ID, student dot student ID, student dot name, subject dot subject name, and student subject dot marks. From the child table, student subject marks. Inner join student table on student ID. Then again inner join subject table on subject ID. That's it. Now I'll just create these tables. So stay connected so that we can implement the things practically. I'll add a table. Student ID as int, student name as varchar 50, then gender. So we are not going to have a lot of fields, just 3 fields. I'll save this table as student, and student ID I'll make it as a primary key. I'll say save, and I'll just refresh this. I get the student table. Then I'll add another table, subject ID of type int, subject name of type varchar 50. That's it. I'll have only 2 columns. I'll name it as subject, and I'll make subject ID as primary key. I hope you should not have any doubt in this. These are simple things. I'll just refresh this. Student and subject. Now I'll add one more table, that is student subject ID. So for this we will have some primary key, that is student subject ID. This key I can make it as auto increment because it is not very important for us. And then student ID that I am getting from student table. Subject ID I am getting from subject table. Then marks I'm getting I'm going to make it as int. This will be the primary key, and is identity I'll make it as true, and I'll save this as student subject. Now I'll refresh this. I'll go for database diagram. I'll just look into this diagram, and here I'm going to add all these three tables. If I want, I can have separate diagram as well. So better I'll go for another diagram. In this diagram, I'm going to add student, student subject, subject. And here you can see that I'll drag student ID, drop it on student ID, say OK, and I'll save this. Yes, that's perfect. So for subject ID, drag it on subject ID, drop it on subject ID, say OK, OK, save this. I'll say yes. So we got the relationship. I can right click and say arrange tables. So it will arrange the tables properly. Save this. Now I will add some records. I'll just go for subject. I need to add in some parent tables first. Subject ID 1000, maths 1001, physics 1002, chemistry. Fine. We have one more. I'll add 1004. I'll go for student. Edit top 200 rows. Student ID. I'll start from 1. Student name Peter, male. 2. Jack, male, male. 3. Lily, female. 4. Bob, male. 5. Mark, male. So we got the data in master tables. Now coming towards our child table. Student ID 1, subject ID 1000, marks 56. Student ID 1, subject ID 1001, marks 65. Student ID 1, subject ID 1002, marks 67. Student ID 1, subject ID 1003, marks 80. What it says? Insert conflicted with the foreign key constraint. Okay. Do we not have 1003? Subject ID No, we created 1004. So let us make it 1003. Are you all good with this? For 2, I'll just do one thing. I'll try to copy this. Okay, foreign key constraint. Fine. The 2, because we have identity columns, right? So we need to hard code it. There is no other 1066 3. You don't worry about this auto incremented because we failed many times, so it is incrementing and it is not going to decrement. We have already learned that, right? 1001 87 for 2 1002 45 for 2 1003 34 for 3 1001. How many students do we have? 5. 3 1002 66 3 1003 54 3 1000. We have not inserted the record for 1000. So 1000, that is 97. 4 1000 4 1001 87 4 1002 4 1003. So that's it. Let us have only these records. Now I'll come back to my query. New query window, or we have our old query window. Fine. Now let us see all these tables. Select star from student. Got the records? Control A, copy, refresh this, new query window, paste it here. Okay. Database diagram also we have refreshed. Select star from subject. Got. Select star from student subject. Fine. Now what I will do, what is the expected result that I want? Student ID, name, subject name, marks. So I'll say select student ID. So student ID, I'll get it from student table. So student dot student ID. Don't worry about this red line. Sometime IntelliSense work and sometime it will not. So if we need to restart Visual Studio, then the things will be good. Or your management studio, then the things will be good. So student dot student ID. Then we want subject or student dot student name. Student name. Then we want student dot or subject dot subject name. Subject dot subject name. And finally we want subject student subject dot marks. Student subject dot I hope you should not have any doubt in this. We have not written anything new. From student I am taking student ID. From student I am taking student name. Student ID, student name. From subject I am taking subject name. From that is subject name. From student subject I am taking marks. From student subject I am taking marks. Is this clear till this point? Now I'm going to show you how to write joins. Do anybody have any doubt till this? Selecting columns. This is the first thing. So shall we proceed? If you are okay with this, then I'll proceed. Fine. From, first of all, I'll go for the child table. From student subject, you can join any table. From student subject, you can join any table. So I'll join student first of all. I'll join student. From student subject, join student. On what column? Student subject dot student ID equals to student dot student ID. On student subject dot student ID equals to student dot student ID. Is this clear till this point? Anybody any doubt? Now what you can do, you can just remove this subject. If I remove subject, then I'll get student ID, student name, marks. So it is simple join on two tables. Student ID, student name, marks. But I want subject as well. I want subject as well. So I need to say same, just say tab, join, same thing. Now join subject table. On what? On same student subject dot student ID or student subject dot subject ID equals to subject dot subject ID. That's it. Peter, math, physics, English. Jack, math, physics, English. Lily, you have. Bob, you have. Now you can see this child table, join parent table on so and so, join another table on so and so. In the same way, join one more table on so and so, join one more table on so and so. In this way, you can keep on joining n number of tables if you have relationship. If you want to alias this student subject as SS, student as ST, and subject as SB, we are aliasing. So here I'll say for student ST, student ST, subject SB, student subject SS. I'll say SS dot student ID equals to ST dot student ID. SS dot subject ID equals to SB dot subject ID. The same thing, but we have simplified it a little. So if you have anything to ask, you can ask. So this is very important, writing joins on multiple tables or more than two tables. So is this clear? Why we took SS table first? Because I told you the best approach of query writing is taking the child table on the left and parent table on the right. In yesterday's session I told we took employee table as left table and department table as right table. So we started with child. So that is the best approach. Start with the child. So by looking at the diagram, you can understand. Student subject joins student, then same student subject joins subject. So that is this. Now, if I want student ID, student name and average marks. See, in my assignment, what I gave you as marks 1, marks 2, marks 3, three separate columns, and you are saying marks 1 plus marks 2 plus marks 3 by 3. That is not the right approach to store marks, but this is the right approach to store marks. Because tomorrow, marks 1, marks 2, marks 3, they can get marks 4, marks 5. So we need not to keep on adding columns, but rows you can keep on adding. So this is the best structure for that. Now, if I want to calculate average, Then what I want, student name. So I will group by student name and I'll perform average on marks. You can see that. I'll copy this. Subject name I'll move. I'll remove subject name. And marks I will just write sum. First of all, we'll try to find the sum of marks. And we'll name it as total. And we can also find AVG average of SX dot marks. We'll name it as average. Now group by student ID and student name. Now you see the result. Peter got total and average 67. Jack total and average. Lily total and average. Bob total and average. Copy this, paste it here and say order by total. Descending. So Lily is the topper, then Peter, then Jack, then Bob. If I say select top one, then I'll get the topper in the class. So this is the query writing approach. If somebody asks, if somebody gives you this database diagram, and they ask you, I want you to write a query to find the topper in the class. So don't start with select top one. This is the query writing approach. First you write join, then you write group by, then you go for order by, then you select top one. If you have understood this query, means you have understood lot. Your assignment for the day is this. I hope you might have created this database and you inserted records, right? You might have created this database and inserted the records. Yes or no? If not, so your assignment is create this database, insert the record, and write a query to display order ID, customer name, toy name, then the category name and plant name, quantity, date of order, and ship to address contact person name. What are the things I want? Order ID, I'll get it from here. Customer ID, I'll get it from here. Toy ID, toy name, I'll get it from here. Then I want category name, and also I want plant name. And then I want quantity, date of order, and ship to address contact person. So now I need to write join on how many tables? 1, 2, 3, 4, 5, 6 tables. Have you understood the assignment? From this database, I want you to write a query. Okay, create this also then. If you have created IT workshop management, that is good. Create even this. And the information that I want is order ID, I'll just write a notepad. So you see this is the information I want. Order ID, customer name. For this particular order, who is the customer? Customer name. And then I want toy name. The customer has placed an order for a particular toy, right? With toy ID, I can get toy name. And I want to know to what category this toy belongs. Category name. And I want the plant name. Plant name. And I want the contact person for ship to address. And again, I want the quantity of this order and date of order I want, and ship to address contact person name. So these are the things that I want to display. So order table is connected to customer table, so I can get the customer name from there. Order table is connected to toy table, I can get the toy name, and toy table is connected to category, so I can get the category name. Category is connected to plant, I can get the plant name. And order table is connected to, in order table we have quantity, date of order. It is connected to ship to address, so from there I can get ship to address person name. Write a query to display these things. From stock management system. I hope now the requirement is clear. This is the way I have explained. Just join this on this, then join, then join, then join. You keep on writing joins. Try and try unless you succeed. So if you write this query successfully, means what? You can write any kind of join in the universe, because this join has all permutation and combinations that we normally have in our real-time project. So you take one full day try joining two tables, get the data, then join third table and get the data, then join fourth table and get the data, then join fifth, then join sixth. So get the information step by step. Don't try to write join on all 6 tables at once. I have shown you, right? First we have joined student and student subject. Then we joined student, student subject and subject. So proceed in the same way. So I hope now you understood the question. What query you need to write. Everyone. Ashok, Muhammad, Shams. Very good. Ashok understood the requirement. What about Muhammad? Very good. Shams? Very good. Create the database with full patience. Insert the data with full patience. Then start writing query with full patience. From whole day, if you are able to write this join, then I am very happy. Now after writing that join, you can get lot of reports from there. Like I have shown you this as one of the reports. Fine. Now we'll move ahead. There is one more concept, that is self-join. Basically, you have this kind of scenario, but one of the famous scenarios that people normally ask in the interviews is this scenario that we are going to discuss now. Self-join. Joining a table with itself is called as self-join. The best scenario is if I want to know who is the manager for particular employee. So manager is also an employee, right? Manager is also an employee. Joining a table with itself is self-join. Now this is how we represent self-join. Employee table, employee name, so and so, then manager ID. This manager ID is again employee ID because manager is also an employee. This manager ID is again an employee ID. Now, just to understand the things easily, I'm not going to touch the existing database design because we might be using that in our future sessions. I'm going to add one more table to this. Add a table, emp ID, int, emp name, varchar, gender, varchar, and we want manager ID. Who is the manager for this employee? So I need to say manager ID as int. So employee ID is primary key. Save this table as EMP. That's it. Now I will add a database diagram, new database diagram, and here I'm going to add EMP. That's it. Save. Manager is also an employee, right? So I'll drag my employee ID and drop it on manager ID. Same. This becomes a self join. Save this. This is how you represent self join. See, employee ID is null. I'll just refresh this, and I'll also refresh this. Manager ID allow null. Foreign key can have null values. Now I'll go for the top 200 rows. Employee ID 1, Peter, gender male, and manager ID is null. Means this employee has no manager. It means what? This employee itself is a manager. Employee 2, Jack, male, null. Employee 3, Lily, female, and for Lily manager is Peter. 4, Bob, male. For Bob manager is Peter. 5, Ricky, male, manager is Peter. 6, Mark, male, manager is Jack. 7, Tom, male, manager is Jack. 8, Mark, male, manager is Ricky. Is it meaningful? Who is the manager for Lily? 1. His manager ID is null. That's fine. So he is top level manager. Same, same, same. For Mark, manager is 2. So that is 2. So Jack is the manager. His manager ID is null. So he is top level manager. For Mark, manager is Ricky. And for Ricky, manager is Peter. So Ricky is not top level manager. Ricky has another manager over him. So this is the information that we have. Have you understood the database table structure first of all? Everyone say yes or no. No, user and user role is not the example over here. This is totally different. This is not user and user role. This is similar to something. See, customer complaints. Say we have customer complaints. So there is a person who raises a complaint. So of a particular customer ID and the complaint and raised by so and so representative. Now the same representative can be a customer again. Okay, we'll go for that later on. First of all, let us try to understand this. You have employee ID, employee name, gender. Now who is the manager for this employee? We will be representing with manager ID, because manager is also an employee, so I'm not going to have separate manager table. Same employee ID I'll join over here. It is so simple. Now the important thing is select star from EMP. If I say, I'll get the information. Now I want employee ID, employee name, gender and manager name I want. So what is the manager name for 1? It is null. What is the manager name for 2? It is null. What is the manager name for 3? Peter. Who is the manager of Bob? Peter. Who is the manager of Ricky? Peter. So I need to join this table with itself. That is self join. So what we need to do, we need to logically have same table as another table. Now I'll say employee E dot EMPID comma E dot EMP name. Employee ID, employee name I'm getting. Now I will say inner join same EMP. Join this table with itself. But now I'll name it as M. Now I will name it as M. This is manager table now. Now same employee table is acting as a manager table. And this time I'm going to track m.emp name as manager. But join on what column? On employee dot manager ID, employee dot manager ID equals to m dot manager dot emp ID. Now let me execute this. Because it is inner join, we are getting. If I say left outer join, you'll get even null. All from left table. Peter manager is null. Jack manager is null. Lily's manager is Peter. Bob manager is Peter. Ricky manager is Peter. Jack manager, Mark manager is Jack. Tom manager is Jack. Mark manager is Ricky. Now you see this diagram, you will understand the things. I hope you understood this relationship first of all. Now what I will do, I'll take same table as employee 1. Now same table replica. Logically I have two tables now. This is employee table, this is manager table. Now employee table's manager ID is equals to manager's table employee ID. That's it. This is acting as a manager table. This is acting as an employee table. So employee table dot manager ID is equals to manager table dot employee ID. That's it. Now if you see the query, employee table dot manager ID equals to manager table dot employee ID. Select star from emp, alias it as e. Same thing, copy. Select star from emp, alias it as m. So this is logical. Now assume that this is your employee table and this is your manager table. So employee table dot manager ID equals to manager table dot employee ID. We are mapping with this. I hope now you should get. Now 1 Peter male null, 2 Jack null, 3 Lily Peter, 4 Bob Peter, 5 Ricky Peter, 6 Mark Jack. So I hope this is the simplest. I have tried my level best to simplify as much as possible. You have to think logically one table as two tables. Or in other words, we have only one table employee. We are creating two objects of it. One is E, another is M. E dot manager ID equals to M dot employee ID. See, what we have seen joins. Joins are similar to your multiplication. Whereas union, these are similar to your addition. Normally in our query writings, we majorly use joins. We hardly use unions. But maybe in the interviews they may ask what are unions, and there are few scenarios where we use unions. Say for example, union used to append records for more than one table. Same, we have few unions. One is union all, union, intersect, except. So these are the things that we have: union all, union, intersect, and except. We will understand one after the other. Let us assume that you are running a business, say online shopping cart, some XYZ online shopping cart, and you thought of acquiring some other businesses as well, which are other online shopping carts. So you contacted that admin and you asked them to buy their you asked them to sell their business. So you bought their business. Now your business is also related to your online shopping cart, and their business is also related to online shopping cart. Now you want to merge these two businesses databases, or let us assume that the customers. So there are scenarios where both of them may have same customers. Both the businesses may have same customers. So I have customer business A table and customer business B table. Now if I see, I have customer ID, customer name, address and contact. Even here I have customer ID, customer name, address, contact. IDs may differ, but if you say Jack, do we have Jack customer here? No. Peter we do not have. Tom, yes, Tom is here. Lily is also here. Ahmed is also here. But Bob we do not have. Adam we do not have. So we have two different tables. Now I want a report that should club these two tables data. So it is like addition, customer business A plus customer business B. So I'll say select. I need to select the common columns, the columns which are common in both the tables. Name, address, contact from customer business A, union all, select name, address, contact from customer business B. So what it will do, it will select all this column plus these columns, or all these records plus these records. You see Jack, Peter, Tom, Lily, Ahmed, then Tom, Lily, Ahmed, Bob, Adam. Simple concept. Now I get a report where I have all the customers from both the tables. With their information. Simple union all. If you say union, then it will remove the duplicate records. Tom, Lily, Ahmed. Tom, Lily, Ahmed is being repeated. You see this. So these are the duplicate records. So it will remove that. Union, you will have Adam, Ahmed, Bob, Jack, Lily, Peter, Tom. You do not have repeated record. Tom, Lily, Ahmed. Tom, Lily, Ahmed. Tom, Lily, Ahmed. You see this only once. So altogether, how many records do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So out of 10 records, 3 are being repeated. So if I say 10 minus 3, I should have 7 records. 1, 2, 3, 4, 5, 6, 7. So same union, but it will remove the duplicate records. I will get the unique customers list. So in other words, it is distinct of union all, you can say. In other words, it is distinct of union all. This is union, simple concept. Next is, I want the common customers. Tom, Lily, Ahmed are common customers. So I will use intersect Tom, Lily, Ahmed. These are the common customers in both the businesses, or customer business A table, customer business B table. If I say intersect, I'll get common. So it is similar to your A intersection B. So this is your intersect. Now, if I want all the customer of B, but except these three things, so like A minus B, or I want all the customer of A except the customers which are in B. So A minus B, or if I want all the customer of B except the customers which are in A, so that is B minus A. That is this. I want all the customers from business A except the customers which are in business B. So I have Jack and Peter. Tom, Lily, Ahmed are in business B. So I'll exclude that. Jack and Peter. If I want Bob and Adam, then I'll write customer business B, customer business A. So that is your except. So it is A minus B. Simple thing. the famous interview question is the difference between union and union all. They may ask, what is the difference between union and union all? Union will get the duplicate records, whereas union all will not get the duplicate records. These unions example, again I need to add two tables, customer ID int customer name only these columns. That's it, 3 columns. Customer ID, I'll set it as primary key. I'll set table as customer. Now same way, there is no relationship between these two tables. These two tables are independent tables. For joins we need relationships, but for unions we do not require relationships. Customer ID int customer name varchar and gender varchar. I'll set this as primary key and I'll make it as identity column which starts from 1000. I'll save this as customer B and this I'll make it as again identity column and let it start from 1. You can mute your mic so that we should not have any kind of, I'll just mute all. Fine. Now I'll just refresh this. You got customer A, customer B. I'll just try to add some records. Peter, male. Jack, male. Lily, female. Bob, male. Mary, female. Now I'll go for customer B. Here I'll have long, male. Ricky, male. Dinah, female. Peter, male. Tom, male. Do we have Peter and Tom in customer A? Peter we have. Tom we don't have. I'll write Jack. That's it. So we got some information. I'll write queries. Select star from customer A. Copy. Select star from customer B. So I should get information. Now if I simply say customer name name and gender, same column. See, these columns should match. You should have same column names. and here I'll say union all. Peter, Jack, Lily, and if you want you can say order by customer name. You have Bob, Diana, Jack got repeated, Lily long, Mary, Peter got repeated. So this is your union all. You'll get all the records. If I say only union, then you will not have, see here we have 11 records and we have two duplicate records, 1 and 2. So now I should get how many records? 9 records, which is excluding these two. That is union. Then you have intersect. Intersect will give you common records. So I have two common records, Jack and Peter. These are the common records. If I want minus, I want A minus B. So except. Simple. The terminology itself has the meaning. Bob, Lily, Mary, except those two records. That is Jack and Peter. If you want B minus A, then I'll say customer B minus customer A. So there are a lot of scenarios where you want to merge the data. So for example, you are running a call center and there are few centers that were you are running earlier, and now you have acquired those call centers and you want to merge those customer data, or you have request and you want to merge request. And see, sometimes the customer may call and they'll say that I have this problem, and you'll raise a request. Again, the same customer may call and he may try to log the same request. So due to some kind of miscommunication, they may again log the same request. So even that is also one of the scenario where you can go for or you have one unit in Hyderabad, another unit in Chennai, and he called the Chennai unit. So there are a lot of scenarios where you want to write reports, you want to generate reports. Especially this is related to your reporting services. When you go for reporting services, you will have all these kind of combinations. But once you want to work on some kind of applications, then these are hardly used. For your applications, we basically use our joins. But anyway, because we have unions as one of the major topics being discussed in the interviews, so I thought of including that. But it is very simple. I hope you got the point in this. There is nothing very complex in this. Self-join is also very important. From interview point, union all and union is important from interview point. Whereas from implementation point, joins are very important. The assignment that I gave you, that is very important for real-time project implementation point. So joins are very important for real-time project implementations and interviews. But for interviews, apart from joins, they will ask about union, union all, self-join. So these are the things they'll ask. So you need to prepare for both the things at the same time, for interviews as well as for implementations. Fine. Do anybody have any doubt in this? Did we close all the queries that we wrote earlier? I'll try to merge all the queries on single window. Copy this. We have all our queries here, right? This is related to self join. This is all about your unions. Self join and union. So this is the assignment that you have to work out on. So is this clear? The next topic we will start on Monday. For today, I think this is enough. Next topic is your subqueries.